So, problem number 3, 4, and 5. Compute the brake power. So, brake power na naman. In megawatts that can be generated by turbo diesel engine with meron kang binigay na efficiency. Okay? Running at 1,200 RPM if it has a bore to stroke ratio of 1 to 2. The engine has 12 cylinders. Oh, ito, di ba? Ito yung sinasabi ko sa inyo, binigyan ka ng pressure, ibig sabihin, pwede mo makuha yung brake power. So, 4-stroke siya, and develop mean effective pressure, and then the length of the stroke. So, the length of the stroke, yung bore, ito yon. Yung length ng stroke, ito yon. Kung cylinder yan and piston. Okay? This is the bore. Okay? Diameter ang tinutukoy. Ito yung stroke. Okay? Ito yung optimal pressure na nag-ooperate yung engine mo. The mean effective pressure. O anong turo ko sa inyo? That the work net or the work ng engine is equal to MEP multiplied to the volume discharge. Sir, elaborate. MEP is equal to, MEP is equal to, MEP multiplied to VD. Di ba ang VD is langka? Di ba? Recall natin that K, kapag 2-stroke, 1. Kapag 4-stroke, 1/2. Lagay mo dito 4-stroke. Ayan, So, ilang cylinder ang binigay sa'yo dyan? 12. Number of acting, single lang yan kapag hindi sinabi. Okay? Pwede na yan. Masasolve na natin yung work net. Okay. Pero ang hinahanap kasi natin dito is the brake power. Okay? Yung efficiency is equal to yung brake power divided by yung brake work dito. That can be generated. So, generated. Okay, mas maliit yan. BP, tama. Dito yung input power. Okay, internal power. Okay, indicated power. Okay, ito yon. Okay. So, BP ang hinahanap natin. BP, mas maliit dapat yan kesa dito sa IP. So, E multiplied to MEP multiplied to lang ka L. Yung area ng bore, okay, that is pi over 4 D squared C K A. Okay, this is 1. Number of cylinder is 12. Buo na, pwede natin masolve. So, that is 0.812. Yung MEP, anong binigay dyan? 1,200 kilonewton per meter squared. The length of the stroke. The length of the stroke is 1.2 meters. 1.2 meters. Ibig sabihin, yung length mo is twice as long nung iyong bore. Okay? Okay. So, yung bore mo is pi over 4 multiplied to yung D squared. Kaya lang, diameter ang binigay dito. Kalahati daw yung bore mo nung 1.2 meters. O ilan yun? Ay di 0.6 or 1.2 divide by 2 meters. And then, square mo. And then, C, number of cylinders is 12. K is 1 over 2. And then, single acting. Tignan natin yung unit. MEP, L. Kulang pa tayo ng N. Yan. Multiplied to N. Ano yung N mo dyan? That is 1,200 RPM. 1,200 RPM. Ang problema, naka-kilonewton yan. Okay? Kailangan natin is the factor 9,549,123 Newton millimeter per kilowatt RPM. Dapat maging kilowatts muna. Ito kasi matitira. Tignan nyo. Meter squared, meter, hindi, ito na lang. Meter squared, ayan, dito nakuha. Tapos yung RPM, RPM, Newton, millimeter. Dapat to maging Newton. So, i-divide pa natin yan ng 1,000, hindi, i-multiply natin. 1 kilonewton in every 1,000 newtons. Tapos, yung meter, para maging millimeter, 1 meter in every 1,000 millimeter. Pwede na yan. Okay? Megawatt ang hinahanap natin. Mamaya natin convert. Ang lalabas po dito is kilowatts. So, let us solve. 0.812. Masanay na kayo. Ito talaga yung mga pinakamahihirap na ibinibigay sa atin. Times 1.2 times shift pi over 4. Kaya masanay ka, ilista mo muna bago mo ilagay sa calcu. Times 0.6 squared times 12 divided by 2, 6. Simplify mo na kapag kaya. Times 1,200. Divided by 9,549,123 times 1 divided by 1,000 squared. 1,000 times 1,000. Okay. Ang lalabas is kilowatts. Okay, na kilowatts. Sir, in 1 kilowatt, we have, or in 1 megawatt, 1,000 kilowatts. O, divide natin ng 1,000 kilowatts to. So, the answer will be 249 megawatts. So, the brake power is equal to 249.279 megawatts. Okay? 1,000 kilowatt in 1 megawatt. Okay? Lagay natin dito para hindi ka nalilito. There are, in every 1 megawatt, 1,000 kilowatts. Cancel all the same units. Pam, pam, pam. Yan, ito. So, ang natira is megawatts. Check. Very basic ang number 3. Kailangan mo lang alamin yung tamang paggamit ng given. Okay? So, number 4. An ideal combustion cycle operates. Combustion cycle. Ideal dual. On 1 kilogram of air. So, that is the mass of air. 1 kg. At the beginning of the compression, air is at beginning of compression, therefore, that is P1. 100 kPa. And the temperature niya is 40 degrees Celsius. So, meron ka ng M. Okay? Throughout the system, M is constant. Determine the volume at the end of the compression. So, anong hinahanap? V2. Okay? So, drawing natin yung dual cycle combustion. Hanapin natin yung formula niya. Nandito sa fuels and combustion. Ayan. Dual cycle. Okay? Yun. Let me get this. Yan. Ilagay natin dito. Makikita nyo, this is the beginning of the compression and then this is the end of the compression. Okay? Now, ang hinahanap nyo dito is V2. Since the process is isentropic, then therefore, we can get the value of V2. Sir, paano? Meron kang network. Yes. And then, meron kang mean effective pressure. Tignan mo di ba ang mean effective pressure is equal to the work net of the cycle divided by the volume discharge. Okay? The volume displacement of the entire cycle. Now, di ba ang VD mo is equal to the maximum volume minus the minimum volume, which is V2. Okay. So, MEP now is equal to work net divided by V1 minus V2. Are you given V1? No. Pero saan mo isosolve si V1? Sir, recall natin si PV is equal to MRT relationships. Okay? Yan, the ideal gas law. And we are talking about air here, which is an ideal gas. So we can solve for B1. O, pwede nating ipasok lahat yan sa isang equation. Ang hinahanap natin is V2. Then, pwede na, di ba? O, algebraically, okay, let us put this aside. Yung V1 mo is equal to M R T1 divided by P1. O, dito natin ilalagay si V1. Okay? Pero mamaya natin yan i-simplify. Ito muna, i-simplify natin siya in terms of V2. So, V1 minus V2 is equal to work net divided by VD. Okay. Dapat makakaugalian yung mag-simplify niyan. So, ito, matransform na natin siya in order to find yung V2. So, V2 is equal to V1 minus work net divided by V. Hindi pala V dito. MEP. MEP. Yan, MEP. MEP. Okay. Simplify pa natin. V2 now will be equal to V1. Ito yun, no? So, MR T1 divided by P1 minus work net divided by MEP. Okay. Solve natin. So, V2 is equal to, yung M, 1 kilogram, kung di ako nagkakamali. Ayun, 1 kilogram. Tapos, yung R ng air, that is 0.28708 kilojoule in every kilogram degree Kelvin. The temperature given there is 40 plus 273 degree Kelvin divided by the pressure. Okay, yung pressure ng 1. I think that is 100 kPa. Yes. 100 kilonewton per meter squared. Ang lalabas dito is meter cube. Minus work net. The work net is kilojoule. 750 kilonewton meter. Divided by MEP. What is MEP there? 1.2 MPa. Gawin nating kPa. So that is 1,200 kilonewton per meter squared. So, ang lalabas dito, sir, is cancel natin. Kilonewton. Kilojoule dito, kilonewton meter. Okay, kilonewton. Kilogram, kilogram, Kelvin, and Kelvin. Ang lumabas is meter cube. Dito, kilonewton, kilonewton. Ang lalabas is meter cube. Okay? So, V2 is equal to 0.28708 times 40 plus 273 divide by 100 minus 750 divide by 12. Okay. That will be V2 in cubic meter. Okay? 0.2735604. That is cubic meter. Kailangan natin is cubic foot. Oh. So, 3.78 at 3.78. 3.28 feet. Okay? I-cube mo in 1 meter cube. So, the answer will be very basic. Okay. V2 is 9.6533 cubic foot. Okay? Problem number 4 is very basic. How about problem number 5? So, 3 boilers operating steadily on 1,000 metric tons. So, binigyan ka ng 1,000 metric tons of high-grade bituminous coal. So, that is the mass total. Contained in a bunker. So, bunker. Okay? Bunker is yung lagakan nila. Okay? Excuse me. The boiler produces, meron kang boiler 1, produces 2,900 kilogram hour of steam. So, for boiler 1, mass of steam, 1 That is equal to 2,900 kilogram per hour of steam at a factor of evaporation. So, FE nung boiler 1, that is 1.19. And efficiency nung boiler na yun, ha? Efficiency of the boiler is 91%. Boiler 2 produces, okay, 4/3 of boiler 1 at 1.18. Ano yung ibig sabihin mo dun? Yung mass of steam mo daw dito, okay, that is 4/3 nung mass ni M1. Mass of steam ni 1. And factor of evaporation daw nito, tingnan natin, ha. Factor of evaporation is 1.18. Napakahaba ng problem na to. Okay, kaya tutok lang, tutok lang. Paborito natin to. And then the boiler efficiency nito is 81%. How about yung pangatlo? The third boiler. Okay? The third boiler is 5/3 of boiler 2. So, yung mass of steam production niya is 5/3 nung boiler 2. MS2. Yun. And then, the FE nun 2 is equal to 1.24. And then, the efficiency ng boiler na yun is 84%. Okay. Now, pare-pareho lang naman po ng coal na ginamit. So, the HHB of the coal is 10,900 kilocal per kilogram. Assume that we have 24 hours operation. Ang hinahanap po natin is, okay, the number of days it will last, yung coal. Drawing natin ito diagram, okay? We are given 1,000 metric tons ng coal. Ngayon, meron tayong 3 boiler. Okay? Yung boiler 1, boiler 2, and boiler 3. Ngayon, paano mo isosolve yan? Sir, madali lang yan. Yes, very basic yan kung alam mo. Okay? Paano kung di mo alam? Kailangan, babalik ka nung sa steam mo. Okay? Aalamin mo si MISPE. Okay? And then yung boiler efficiency. Okay? Mahanap mo sa boiler efficiency yung ano, itong value ng HS and HF. Or yung HS, HF, mahanap mo sa FE. Which is given naman si excuse me. Mahanap mo naman si what? Kunin na lang nga natin to para hindi ka nalilito. Yung factor of evaporation, okay? Lista natin. Yan. The factor of evaporation simply is equal to, balik tayo, topics 3. Yan. Tandaan nyo, note. Yan. Yung boiler efficiency is equal to yung mass ng steam, okay? Tapos yung quality ng steam or yung high and low ng steam mo. Enthalpy ng steam mo sa steam and then sa feed water divided by yung mass ng fuel mo multiplied to the HHB or the higher heating value ng fuel mo, which is coal. And the factor of evaporation is equal to HS minus HF divided by 2257. Non-unit yan. Now, sir, ito yung mga given ko. Okay, this is 1, this is 2, this is 3. What I do not know is yung HS and HF. Sir, saan ko ba pwedeng gamitin yun? Di pa pwede mong isolve yun dito sa FE mo. Pwede mo i-reform si FE as HS minus HF equal to FE times 2257. Turuan ko kayo ng technique ha. And then itong value na 'to puwede mo ipasok dito para mahanap mo yung mass of the fuel consumption nung tagi-isang boiler. Now, okey? Now, for boiler 1, okey? Kukunin mo kasi yung total consumption nitong tatlo, okey? Total consumption. So, meron kang consumption dito ni 1, may consumption ka ni 2, may consumption ka ni 3. Yung dami ng magagamit nilang coal in 24 hours operation, okey? So, makuha natin, okey? O, boiler 1 muna. Mahaba 'to, tutok lang kayo. Boiler 1. Hmm. So, sa isang araw meron kang efficiency ng boiler ang hinahanap mo is mass of fuel. The mass of the fuel ni 1 is equal to, yan oh, M is HS minus HF divide by efficiency ng boiler. Boiler 1, so 1 multiplied to HHV. Tagal talaga 'to. So, pwede ng ganito yan where HF and HS is MS FE 2257 divided by yung efficiency ng boiler mo times HHV of the fuel. Oh, MS. Ano yung MS mo? The MS is mass of steam, 2,900 kilogram per hora. Multiplied to yung FE na binigay sa'yo dyan. That is 1.19 multiplied to 2257 divide by efficiency of the boiler, 91, 0.91. Yung HHV ng coal, okay, that is 10,900 kilocalories. Kailangan kilojoule yan. 10,000 kilocal per kilogram. Ito kasi 2257 kilojoule per kilogram 'to, eh. Okay. So, 10,900 ba 'yun? Hindi ako nagkakamali. Yung 10,900 kcal per kilogram. O multiply mo na lang, 4.187 kilojoule per 1 kilocalorie. Paulit-ulit na proseso 'yan. So, lista mo lang muna, mamaya mo na i-solve para isahan na lang. Ganito yung technique. So, mass of the fuel nun 2, MS mo ulit, ang sabi diyan that is 4/3 nung MS1, 4/3 nung mass of steam dito, 2,900 kilogram per hour. Pareho lang yan nito, 1 point 1.18 times 2257. Ulitin mo lang yan, eh. Kilojoule per kilogram divide by yung efficiency na binigay sa'yo diyan, 0.81. 0.81 times 10,900 kcal per kilogram times 4.187 kilojoule per kilocalorie. O, set aside mo muna 'to. Ang lalabas diyan, kilogram per hour lahat. So, mass ng fuel nung sa 3, consumption niya, that is 5/3 nung MS2. Okay? So, 5/3. 5/3. 'Di ba ang MS2 is 4/3 nung MS1. O di 4/3 nung MS1, 2,900 kilogram per hour multiplied to 1.24, tama? 1.24 times 2257 kilojoule per kilogram. Ano ibig sabihin nito? 2257 kilojoule per kilogram to turn steam, okay? To turn 1 kilogram of steam. Ganun ata yun. Kung hindi ako nagkakamali. To evaporate. Ayun, to evaporate. And, ano yung nasa baba? 0.84 times 10,900 kilocalorie per kilogram times 4.187 kilojoule per kilogram. Okay. Makukuha natin dito yung mass total. Okay, the mass total nung consumption that is yung mass nung 1 plus mass nung consumption ni 2 plus mass nung consumption ni 3. Okay. Paulit-ulit lang yan. Unahin natin yung nasa taas. That is 2,900 times 1.19 times 2,257 divide by 0.91 times 10,900 times 4.187. Store natin to kay A. Okay, kilogram per hour to This is A. Yung B. So, lagay ko na rin dito. 187.5451 kilogram per hour. Yan yung kanyang consumption sa A. Ulitin natin, naka-A. Yung kay B, ulitin natin. Ito, 2,900. 4/3 yung nasa taas. 4/3. Tapos 1.18. 0.81. Yun. 278. 278.5709 kilogram per hour. Store natin to kay B. Ngayon, meron na dagdag. 4/3, 5/3 naman. 5/3. 1,900, 1.24. Ganito lang po mag-solve yan ulit-ulitin nyo lang. The answer is 470. 470 4679 kilogram in every hour. So, this is to C. Yan. A, B, C. Makuha natin yung mass total. What is the mass total? Alpha A plus alpha B plus alpha C. The answer is 936.5839 kilogram per hour yung consumption ng tatlong boiler. Okay? Pero meron tayong binigay dito mass of the fuel sa bunker. That is 1,000 tons. Multiply natin ng 1 ton, 1,000 kilograms per 1 ton. Di 1 million kilograms. Ang hinahanap natin is the number of days. Ayun. So, i-divide natin, okay? As is ko na to. Okay? 1 million kg ng coal. So, the number of days it will last, di 1 million coal, kilogram of coal, divide mo nung total number of consumption niya per hour. So, 936.5839 kilogram in every hour. O, kailangan mo ng 24 hours. Okay, meron kang 24 hours per day. O, ilan days daw maglalast yung fuel mo. So, cancel all the same units. Kilogram of coal, hour, nasa baba yung day, itaas mo. So, ilan days tatagal. So, store natin to kay A. Okay, 1 million. 1 million kilograms of coal divide by. Okay. The answer is, ayan. Uy, hindi ko na multiply yung 24. 9, recall A, times 24. Yun. 44 days. The answer is 44.49 days. It will last for that long. Okay? That is for problem number 5. Ganun lang po yung tamang pag-solve sa kanya. Yung mga samples nito sa book, dalawa lang. Dalawang boiler lang. Ito, 3. Sometimes, ang binibigay ni Sir John, 5. Pero, pag sinundan nyo itong solving ko, sure ako sa inyo, kaya nyong isagutan yan. Okay? That is for problem number 5.